So in this video, we're going to look at some different ways that we can declare variables using different types, and then also some basic input and output. So this example is on your Canvas page. It's under types underscore input underscore output. What I would recommend is download it and open it in WordPad. Some of the other editors are trying to copy and paste directly from Canvas will sometimes insert some strange characters, which will make it difficult to debug and get your program working. But WordPad seems like it always works without fail. It will make your file look really ugly though, so just be aware of that. So we're just going to go in here, click in this WordPad, click Control A to select everything. Now it's all selected in blue, and then click Control C to copy it to clipboard. Then we're going to go into code blocks and click on create a new project, and we're going to always do the console application. It's the same thing in Visual Studio. You do console application, and then if you're using online GDB, in there you just select C++17 in that upper right hand corner. So let's call this example and Jan 31st. Whoops. Make sure that you don't put any spaces in the project title. Make sure that the folder has the correct path. Next and finish. Double click on sources and then double click on main.cpp. This opens up this Hello World program. If you're using Xcode, there's some really important stuff inside of the parentheses and int main, in which case you probably want to paste your program down here, the one that we just copied, and then move the stuff that was before int main up before it, and then move the stuff in between the parentheses and int main between the parentheses. But with this one's just int main and it's empty with code blocks, Visual Studio, or online GDB. So just delete whatever's in there and then just do a Control V, and that'll paste what came from the clipboard from that WordPad file. You can see that once we get it in the code blocks editor, now it's a lot easier to read. So let's just run through the program. So we have our preprocessor directives. So these are our include files in this case. So we're going to use two sets of libraries, one IO stream for input and output, and then the other is string, which is the easiest and simplest way when we're just getting started to work with strings. Strings are just collections of letters and numbers. So things like names, street addresses could all be strings. Here's our int main. Your program will always need to have a main. Main's going to be what's executed when your program runs. And notice we've got int main, we've got the open close parentheses, or it can have a void in there. Either one of those is fine. And then it has the open brace here, and then down at the bottom it has that close brace. So one source of errors is if when you're copying and pasting, maybe not getting that close brace in there. So always just kind of double check that you've got everything between the open and close brace. So now we're going to look at some different variables, and in C++ these are called different types. So we have type int, which we could use to store whole numbers. These could be positive, negative, or 0, but they won't have anything that's to the right of the decimal. So to set up these whole numbers, we just do int for integer and then give it a valid name. And then you can initialize them three different ways. So one way is just don't initialize them at all. So just int the name and then the semicolon. The other way is you can initialize them using an equal sign. So int a is the name equals 0. It's going to take that 0 and store it in main. The other way is instead of using an equal sign, you just use parentheses and put the value that you're using to initialize it inside the parentheses. So line 25 here and 26 are doing exactly the same thing. The only thing that's different is line 25 is initializing a variable with the name of A, 26 is initializing a variable with the name of B. So really important here in your textbook on page 40, there's some rules for what's allowable with these names, and then there's a table on that same page 40 that has keywords keywords are built-ins to C++, and you can't use those for names. Names in C++ are called identifiers. So we would say these are valid identifiers, meaning that they're names that are possible in C++. Now we're going to declare some variables that have something to the right of the decimal point, or could also be numbers in scientific notation, and these are called floats. So just the keyword float, the valid name for that you're using as your identifier, and then you can initialize these the same way with the equal sign or with the parentheses, or just put nothing in there at all. And then we're going to do doubles. Doubles are the same as floats, except they just use more memory. So you can put in some larger numbers that would have larger exponents in scientific notation, or smaller exponents in scientific notation, or even just more decimal points due to the larger amount of storage space. Another type that we'll use a lot are character variables. So these are called char, C-H-A-R. And so these would be, we're just going to use the name alpha 1, alpha 2, and alpha 3 for the identifiers for these. But you could also use ABC or XYZ. We just use those up here, so we wouldn't want to use them down here again. And then with characters, what's very important if you're initializing them is the character that you're putting in here could be a capital alpha character, so capital A, capital B, capital C, and so forth. Could be a number, could be a punctuation, but it absolutely has to have single quotes around it. So single quotes means single character, means char. So just keep telling yourself that if it's a char, it's a single character, it needs single quotes. Now if you have a bunch of characters together, then you have a string, although a string could also be a single character, but since a string is potentially multiple characters, then it has the double quotes around it. So the other thing that's a little different about string is that with string, you have to do that # include string up here. And then when you use string, you have to tell C++ that it's coming out of the library. So that means std : in front of it to scope it back so that it can find it in the library. Other than that, everything's the same. Boolean is another type that we'll use frequently in C++. Boolean is a true or a false, or you could use it as a 1 or a 0. So 1 means true, 0 means false, and when you declare them, you can initialize them either way. You could set them equal to 0, which is false, or you could literally set them equal to false. False is a keyword. Just if you use the keyword false, just keep in mind that the F has to be lowercase. If you use the keyword true, then keep in mind that the T for true has to be lowercase. So let's look at some just some basic output and then also some input. So we're going to use cout. Cout comes from IOStream that we included up here. And so with cout, we have to do that std : in front of it to scope it back to the library. Cout uses these less than operators, and you can kind of think of those like a mouth. So whatever is to the right of the operator is going to be eaten by the operator, and then that's going to be digested into the cout stream object. So we're going to send in there the ints where a equals. This is called a string literal, meaning that its value is just that. It's not ever going to change. And you can see because it's a string, it has the double quotes around it. Then we're going to do another set of operators to separate it. And then now we're going to give it a variable. So it won't print out a character A, but it'll print out whatever is in A. So A is going to still contain what we put in it up here, which was the 0. So this will print out a 0 here in place of A. Then it'll print out this string B equals. Then it'll print out the value of B. So you can see how we're using it to print out some strings when they have the double quotes around them, and then without the double quotes, it's interpreting this when it's just a valid identifier as belonging to some kind of variable that you declared up here. And if you didn't declare that variable, then it's going to give you an error and not let you run the program. Then as we get to the end here, we've got an end line, so this ENDL, and that says flush that output buffer. So it's going to immediately print that to the console window, and then it's going to give us a new line. And the way you can kind of remember C out is, remember, it's going to create a console window, right? So C for console, and then out for output. So anytime you want output to that console window, it's going to be C out. We can print out the values of the floats using a very similar statement. Value of the doubles, value of the characters, strings, and bools. Now let's look at doing some input. We're going to use just the really simple way to do input for right now. Later in the course, we'll look at some more sophisticated ways. So like we used C for console and out, so C out earlier. Now we're going to use C in, so console in, to put things in variables from the user typing stuff in through the keyboard with the console window. Now CN is not going to print anything to the screen, so if you just had line 74 in there and you didn't have line 73, it would just do all this stuff up here earlier, and then it would just sit there and the cursor would blink at you, and you wouldn't know at all what the program was expecting. So anytime you use a CN, make for sure that you also have a cout statement above it that tells the user what you're expecting. And when you're using CN, there's not really very much error checking that you can do, and definitely not very much at the point that we're at right now in the programming. So if the user's typing in something that's incorrect, so instead of integers they type in some A, B, C, D, E, F, that'll just create an error in the program. Our program won't be able to handle that. We'll talk later about how to protect our input and how to work around things like that. But for right now, it's got to be an exact match. So tell the user what they need to be typing in with the cout statement, then have your cin statement. You can also have some calculations right in a cout statement. So in this set of cout statements, we're going to say you entered C and D, and it'll print the values. And then the next cout statement, it'll print C, and then a plus sign, D, and then an equal sign, and then it'll actually do the calculation C plus D right in there and then print that out. And then we'll see what happens when we work with a Boolean. So let's run it. Okay, so it printed all this stuff out. The only reason that these are not all on the same line is because we had those inline statements. Otherwise, they'd all just be smushed together all on the same line, and until it wrapped around the screen anyway. And then we need to give it 2 integers, so I'm going to do 1, 2, 3 space and then 4, 5, 6 and press enter. So then it gave us that, it did the calculation, it gave us a value. The only reason it's doing this and it's printing this out is because we specifically told it to print exactly that. This programs only do exactly what you tell them to do. That can be great, but that can also be kind of frustrating. And then let's look at this last one. So if we type in a 1 and a 1 for 2 bools, so that would be true and true, it's going to add those together and get a 2. So it's another thing to kind of think about when you're doing these kinds of arithmetics. How is it defined and how is it set up? So you need to think about, you did a true plus a true, what does that mean? And then how would you interpret that 2 and explicitly tell your program how to do it? Since we're just printing it on the screen, it doesn't really matter. So we're going to go ahead and press enter. That's going to close this out. Now you might have gotten an error or a set of warnings from this. We had a couple variables that we didn't really use, and then we had a couple of variables that we never initialized. So it came up with some warnings. sometimes warnings in one IDE or one system of building programs will be errors in another one. So we never used variable z. So if that gave you an error, what you could do is you could just take that out and then go to the next one on line 34 and take out dz, and then go to the next one and then take that out. And then try that again, and that should have eliminated anything that would give you an error or a warning in your IDE. So let's build it and run it, but it won't affect the running of the program at all. Alright, thanks for watching.